Good day, my dear students. For this week, we shall study another type of function, which is a rational function together with its application. We will also study how to get the solution of a rational equation and rational inequality. Okay, so we define first a rational function. A rational function is a function in the form of f of x, which is equal to p of x over q of x, where p of x and q of x are two polynomial functions, and the polynomial function in the denominator, denoted by q of x, must not be equal to 0. If the denominator of a rational function is 0, then the function is undefined. So that the domain of a rational function is all values of x, where q of x must not be equal to 0. We defined what is a rational function. Now, we also define a rational equation. A rational equation is an equation that contains at least one rational expression. Any real number that satisfies the equation and does not make at least one of the denominators of each smaller fraction equal to 0 is a solution to the rational equation, satisfying the definition of a rational function. Let's solve some examples for us to understand how to get the solution of a rational equation. First example, we have x over x minus 3 minus 2, which is equal to 1 over x minus 3. There are different ways or methods to solve a certain equation. First, you can use the LCD or the least common denominator. Second, you can do cross multiplication. But before we do that one, we first transfer 1 over x minus 3 to the other side of our equation, then equate it to 0. Take note that as we transfer an expression or an integer to the other side of our equation, the signs will change. So we have here our new equation, x over x minus 3 minus 2 minus 1 over x minus 3, which is equal to 0. Then we now get the LCD. Take note, or you notice that our denominators are the same, x minus 3 and x minus 3. Our LCD then is x minus 3. How will we use the LCD? LCD divided by the denominator times the numerator. Okay, so let's have the first expression. LCD x minus 3 divided by x minus 3 times the numerator x is x, minus our second expression is a whole number. And take note that the denominator of a whole number is 1. So LCD x minus 3 divided by 1 is x minus 3 times the numerator 2 is 2 quantity x minus 3, minus the third expression is 1 over x minus 3. LCD x minus 3 divided by x minus 3 is 1 times the numerator 1 is 1, which is equal to 0. So we have x minus 2 quantity x minus 3 minus 1 is equal to 0. We multiply 2 or applying distributive property on the middle expression. Okay, so we copy x. X minus 2 times x is 2x. Negative 2 times negative 3 is positive 6 minus 1, which is equal to 0. That's there. The answer, x minus 2x plus 6 minus 1 equals 0. We combine like terms. X minus 2x is negative x, and 6 minus 1 is positive 5, which is equal now to 0. Notice that our literal coefficient is negative, and we are looking for the value of x. So we have to multiply negative 1 on both sides of our equation to make our literal coefficient positive. Okay, so negative 1 times negative x is positive x. Negative 1 times 5, it's negative 5, which is equal to 0. Applying 0 property. Any number you multiply by 0, it's 0. Okay? So our final answer is x, which is equal to 5. So we have to check whether the given value for x now, or the answer 5 as the value of x, will satisfy the original equation. We substitute x equals 5 to the original equation. We have 5 over 5 minus 3 minus 2, which is equal to 1 over 5 minus 3. Then, on the denominator, we have 5 minus 3, which is 2. And on the other side of our equation, it's the same. 5 minus 3, which is equal to 2. So we have 5 over 2 minus 2, which is equal to 1/2. We get the LCD again, which is 2. Then we have 5 minus 4 over 2, which is now equal to 1/2. 1/2 is equal to 1/2, which means then that x, which is equal to 5, is the solution of the equation x over x minus 3 minus 2 is equal to 1 over x minus 3. Okay, let's have the second example. 3x over 3x minus 6 minus 2x over 2x plus 4, which is equal to 12 over x squared minus 4. Notice that in our denominators, we can still simplify it, or we get the common monomial factor of our denominators. Okay, so let's have 3x over 3x minus 6 can still be expressed as 3 quantity x minus 2 minus 2x over 2x plus 4 can still be expressed as 2 quantity x plus 2, which is equal to 12 over x squared minus 4. The factors of x squared minus 4 are the following: quantity x plus 2 and quantity x minus 2. Now, we are ready to get the LCD of our equation. The LCD are the following. We have 3 times 2, which is 6. We have here x minus 2 and x plus 2. The same with these denominators. So our LCD then is 6 quantity x plus 2, quantity x minus 2. Okay, we do the same process. LCD divided by the denominator times the numerator. Okay, so let's have first this one. Okay, our LCD divided by the denominator 3 quantity x minus 2 times 3x is 3x times 2 times x plus 2 minus our LCD divided by the denominator 2 quantity x plus 2 times 2x is 2x times 3 times x minus 2, which is equal to this LCD divided by these denominators times 12 is 12 times 6. Okay, so we simplify. 3x times 2 is 6x times x is 6x squared. 3x times 2 is 6x times 2 is 12x minus 2x times 3 is 6x times x is 6x squared. 2x times 3 is 6x times negative 2, it's negative 12. But our sign here is negative, so we have positive 12x. 12 times 6 is 72. We combine like terms, so 6x squared minus 6x squared is 0. 12x plus 12x is 24x, which is equal to 72. Divide 24 on both sides of our equation. Our value for x then is 3. We have to check whether the value for x, which is 3, can satisfy our original equation. Okay, so let's check. This is our original equation. We substitute the value of x, which is 3, to the original equation. So 3, quantity 3, over 3 times 3 minus 6, minus 2 times 3 over 2 times 3 plus 4, which is equal to 12, over quantity 3 squared minus 4. We have here 9 over 3 minus 6 over 10, which is equal to 12 over 5. Okay, so 9 over 3 is 3. And the lowest term for 6 over 10 is 3 over 5, which is equal to 12 over 5. Okay, so that we will have 12 over 5. How did we get 12 over 5? 3 times 5 is 15, minus 3 is 12. So 12 over 5 is equal to 12 over 5. Which means then that the value of x, which is equal to 3, is the solution for the equation 3x over 3x minus 6 minus 2x over 2x plus 4, which is equal to 12 over x squared minus 4. You have learned how to solve rational equations. For this video, we will discuss or explore how to solve rational inequalities. Rational inequality is an inequality that contains at least one rational expression. The solution to a rational inequality is a set of real numbers that will satisfy the given inequality and whose elements do not make the denominator 0, so that the function is defined. In solving rational inequalities, we have to give special attention to the inequality symbols like greater than, less than, greater than and equal to, less than and equal to. And of course, do not forget, we will use the interval notation for the solution set of the inequality. Okay, let's have some examples. We have here 2x over 5 plus 3x minus 1 over 2, which is greater than 9. Okay, so our denominators are 5 and 2. And we will still apply the same process like what we did in rational equations. So you have two methods to solve it. You can apply LCD, the least common denominator, or you can do cross multiplication. So we will use still the least common denominator. The least common denominator of our inequality is 10. Okay, so same process, we will divide the LCD to the denominator times the numerator. Okay, so LCD 10 divided by 5, which is 2, times 2x, plus LCD divided by 2 is 5 times the numerator 3x minus 1, greater than 9 times the LCD 10. So we have here 2x times 2 plus 5 quantity 3x minus 1, which is greater than 9 times 10. Okay, so to simplify that one, we have 4x plus 15x minus 5, which is greater than 90. Okay, we combine like terms. 4x plus 15x is 19x, greater than 95. How did we get 95 here? We transpose negative 5 to the other side of our equation, or applying addition property of inequality, 90 plus 5 is 95. We divide 19 on both sides of our inequality, so x then is greater than 5. Okay, so which means then that our interval notation is 5 to positive infinity. We have here a parenthesis, which means 5 is not included in the solution set of the given inequality, which is 2x over 5 plus 3x minus 1 over 2, which is greater than 9. Let's have the second example for solving rational inequalities. Let's have 6 over x plus 2 plus 4 over x minus 2 less than 2 minus 8x over 4 minus x squared. Okay, so we have to transfer the expression on the right side of the inequality to the left side of the inequality. So we have here 6 over x plus 2 plus 4 over x minus 2 minus 2 minus 8x over 4 minus x squared less than 0. We try to arrange the third expression, this one, 2 minus 8x over 4 minus x squared. That is also equal to 8x minus 2 over x squared minus 4. So we have here 6 over x plus 2 plus 4 over x minus 2 minus 8x minus 2 over x squared minus 4, which is less than 0. Okay, so we are now ready to get the LCD of our inequality. We have here x squared minus 4. And the factors of x squared minus 4 are the following: x plus 2 and x minus 2, which are the denominators also of our inequality. So our LCD then is x plus 2, x minus 2. Okay, so same process, LCD divided by the denominator times the numerator. So we have here LCD x plus 2, x minus 2 divided by x plus 2 times 6 is 6 quantity x minus 2. LCD x plus 2 quantity x minus 2 divided by x minus 2 times 4 as the numerator is 4 quantity x plus 2 minus the LCD are the factors of x squared minus 4, which is our denominator. So that will be equal to 1 times the numerator is 8x minus 2. Okay, over our LCD greater than 0. By applying distributive property on the numerator, we have now 6x minus 12 plus 4x plus 8 minus 8x plus 2 over x squared minus 4 less than 0. We combine like terms, so we have 6x plus 4x minus 8x is 2x. Negative 12 plus 8 plus 2 is negative 2 over our LCD x squared minus 4 less than 0. So from this point, we will get the zeros of the numerator and the restricted values for the denominator. First, we have the zeros of our numerator. Our numerator is 2x minus 2, equate it to 0. So 2x is equal to 2 and x is equal to 1. So x equals 1 is the 0 of our numerator. Next, we find for the restricted value of the denominator. Our denominator is x squared minus 4, which is equal to 0. To get the roots of x squared, we square both sides of our equation. Then x is equal to the square root of 4, which is positive negative 2. Which means restricted values. We are looking for the restricted values. So x must not be equal to positive 2 and x must not be equal to negative 2. After solving for the zeros of the numerator and restricted values for the denominator, we are now ready to divide the number line into intervals. And we will use those values as partition points. So we have here our number line. We recall that the restricted values for the denominator our x is equal to positive 2 and x is equal to negative 2. Okay, so here is our negative 2 and here is our positive 2. And this shaded circle here is 1, which is the 0 of our numerator. So we will use this number line to get the intervals. Okay, and we will set the critical values and we'll use the table of signs. So this is our table. On this column are the factors. On this row are the intervals. So we have here the interval, negative infinity until negative 2, negative 2 to 1, 1 to 2, and 2 until positive infinity. So we will just set values of x within the interval. For this one, negative infinity until negative 2, we can have negative 3. And if we will substitute negative 3 to these factors, we will arrive with these signs. Okay, so let's have negative 3. X equals negative 3. 2 times negative 3 is negative 6 minus 2 is negative 8. So the sign is negative. For x squared minus 4, quantity negative 3 squared minus 4 is 9 minus 4, or that is positive 5. And here is our sign, which is positive. Okay, so negative over positive is negative. On this side or interval, we can set x which is equal to negative 1. So 2 times negative 1, it's negative 2 minus 2, which is 0. That should be negative 4, I should say, not 0. Okay, next we have x squared minus 4. We substitute negative 1. So quantity negative 1 squared is 1 minus 4, which is negative 3. So negative over negative is positive. Okay, same is true with this column and the last column. Okay, so which means our interval notation then is negative infinity, negative 2, union of 1, 2. Okay, so we will get only this column where the last sign is negative. Here also, 1, 2, the last sign is negative. Because our inequality has a symbol of less than. So we will only get this one to make our interval notation.